Okay, hi everyone. My name is Franceli. Today I'm gonna read the first 2 pages, 3 pages, depending on how long this video is gonna be. As I mentioned before, or in my first video, I will try to read or kind of study here. In this case, I will read this book that I auto gifted myself for my birthday last year. So yeah, I'm excited. And if you have any questions or ways that I can improve the way I can read, I will appreciate. I hope this can help me a lot to be more confident the way I talk, the way I read, and can be useful in the future for me. So yeah. So section A, Interactions. Chapter 1, The History and Development of Plant Pathology by Richard P. Oliver, School of Bioscience, University of Nottingham, United Kingdom. Prelude. Plant pathology is the science that studies plant disease. It is concerned with how pathogens cause disease and how plants resist pathogens. It describes how diseases spread in time, in place. It also seeks to find methods to protect plants from the impacts of disease. Plant pathology is challenging, interesting, and important. It has the practical and noble goal of protecting the food available for humans and animals and preserving the natural environment against invasive diseases. Plant diseases, by their presence, prevent the cultivation and growth of food plants in some areas. More commonly, plants may be cultivated and grown, but plant diseases attack them, destroy part or all the plant, and reduce the quality of the food and favor products before they can be harvested or consumed. Moreover, they may often, with human help, invade new territories and damage native ecosystems. Plant pathology is an applied science that has benefited from input from a wide range of fundamental and applied disciplines. Much of the current plant pathology research is rooted in microbiology, chemistry, genetics, cell biology, and ecology. It interferes with chemistry and physics. As an applied science, it collaborates with engineers, economics, agronomy, with science and entomology. It has also been the forum in which fundamental knowledge was developed that advanced other sciences. Then, use of pure chemicals to cure disease was first carried out in plants. The concept that germs cause disease was first worked out in plants and later confirmed in studies on animal diseases. Most of the major advances in biology were first made using plant viruses. It is also a successful science. Global human life expectancy increased from under 34 years in 1913 to over 72 years in 2015. The control of plant diseases has played a major role in this increase, via a combination of agronomical packages, pesticides, and genetic disease resistance, even as intensification of agriculture has increased the impact of occasional epidemics. Our understanding of the details of how to design and use pesticides and how to develop and deploy genetic crops, plants, diseases resistance has advanced at an impressive pace over the last decades. Nonetheless, losses to disease have remained persistently high. Recent estimates of losses to disease in six major crops indicate that between 17% percentage and 30% are lost to pathogens and pests, with greatest losses being attributed to fungi, omo- omycetes, and nematodes. Surprisingly, losses are not consistently higher in low and middle income countries. Even in Australia, where disease pressures are typically low and growing methods are not intensive, losses to wheat disease average 19.5%. In addition to the losses caused during growth, we must add the 10 to 30% of the losses of crop after harvest, which are particularly high in developing tropical countries where training and resources such as refrigeration are often lacking. Finally, we should factor in losses caused by environmental factors such as frost, droughts, air pollutants, nutrient deficiencies, and toxicities. Crop losses continue to be direct cause of malnutrition and even starvation. Current estimations suggest that at least 450 million people are chronically underfed, whether from a gross lack of calories or micronutrient deficiencies. It could be argued that as much food is lost or wasted during transport and in the food chain, there is enough food production and that the problem lies with food distribution. Nonetheless, every instance of crop disease on the farm and in storage increases the amount of land, water, and inputs, fertilizers, pesticides, fuel needed to produce the world's food. A time of substantial human-induced global warming, water shortage, and widespread pollution causing catastrophic declines in biodiversity. It is the duty and goal of plant pathology to balance all the factors involved so that the maximum amount of food can be produced with the fewest adverse effects in people and the environment. So now we have a figure where it shows the global variation in crop losses and production. The top left chart shows global losses and production for wheat, rice, maize, potato, and soybean. Mm-hmm. So we have yield losses and production per person in kilograms. Mm-hmm. Okay. Yeah, I think for today was good. I will do 30 seconds of my opinion, and well, not my opinion, like a kind of summary of what I read. And I think it's very obvious. Just explaining why plant pathology is very important, and it's not just in the way of um, food security. It's more dependent than that, and it's just try to have the balance to have a healthy plant that can provide the food that we need as a human to eat. And I think this all is connected. This is connected with what is happening or what happened before in different epidemics in other countries, and so I think it's very interesting, and also how plant pathology is not just about plants and pathogens; it's also about different areas and different disciplines that together will bring the best solutions or the best explanation of different process or things that happen between this interaction, plant and pathogen. So yeah, I hope we are learning something,